Hello everyone, welcome to SciSoft Academy. Here we are empowering the education through digital content, and this is me Mallikarjun, and today we are going to talk about inheritance. What is inheritance and why do we need inheritance? What are the types of inheritance and what are the terms involved in inheritance? And also we will see a live coding session on that. So hope you are excited. So without further delay, let's get started. So, what is inheritance? So, it is a mechanism by which one class is acquiring the properties and behaviors from the parent class. So, what do we mean by properties and behaviors? Properties are nothing but just the data members or variables that you define inside a class. And by behaviors, we meant to say the function definitions or the functionality you are adding into that class. So these two, the data members and the functionality, you can derive from the parent class to child class. So this is what we call as inheritance. So to give you a simple example, let's say this is like a actual parent-child relationship. Let's say the child is inheriting some of the properties from father. Let's say the father's eyes are blues and his hair is white. So the child may inherit the father's properties such as eye color and hair color, and some of the behaviors from his father. So that is what is actually inheritance. And what is it giving to us? So basically, this inheritance gives us the ability to build upon existing classes. So we will define the functionality in a base class, or we call it as a blueprint. So we will build any other classes on top of that blueprint. So that is the beauty of inheritance, and how it is important in our coding session. So, or how it is important in the programming world. So basically, this gives us the ability to reuse the methods and fields from the parent objects. Let's say if we are creating a blueprint or a parent object, if we are defining some of the member variables and member functions inside a class, we can able to reuse the same in the derived class. So derived class also doesn't have to repeat that code. So basically, we are keeping the code clean and maintainable. So, and when we move ahead, the fourth point is actually it represents a parent-child relationship. And we saw a live example, right? So, how we can actually relate this inheritance in real world. So that is why it is called as a relationship. And also we will definitely see a live coding session on this, how it is actually inheriting the properties from parent. Let's move ahead to the next question. Why inheritance? Why do we need inheritance? So basically, this is very important when we try to achieve the runtime polymorphism. So basically, we will be able to achieve the method overriding only through inheritance. So those who are not aware what is runtime polymorphism, we have made the video on this, and that I'm linking into the top tile. So let's go check it out and then come back here. So you will have a better understanding on this. And the second point, why do we need inheritance is because of the code reusability. So we don't have to write repetitive codes. And by using these inheritance concept, we can keep our code clean and maintainable one. Okay. So those are the main reasons why we are going ahead with the inheritance. Okay. And what are the terms involved in inheritance? Let's see, we have been talking about parent, child, and inheriting. So, what are the terms? So what do we mean by them? So, basically, we know how to define a class in Java, right? So, we just declare the classes using class keyword. So, let's say we will just give the access modifiers, whether it's a private, public, or protected. So, and after that, the class is the keyword. And after that, the class name will be there. We will also see a live example on that. Just I'm giving an glance of what these terms are meant actually. And child class and parent class. So as the name itself is self-explanatory, so we will have some member variables and method functionalities defined in the parent class, and we will derive that parent class in the child class. So the child is the one who is deriving the properties from parent. Let's say parent is having two, three data members and two, three functionalities. And child is not having a single functionality or data member. It's having zero functionality and zero data members. Let us assume that. So if we are going to create an instance of child class, the child class will be having access to all the data members and function definitions of parent class. So that's how powerful this inheritance is. So I hope all these terms are clear for you. So now let's see the syntaxes of inheriting from a class. So basically, we know how to declare a class. This is nothing but just public, the public keyword, and class is the keyword to declare a class. And child is just the class name that we are choosing here. So we can choose any name. Just to explain you in a better way, we have chosen child as the class name. And how do we extend it? How do we inherit the properties from other class? We use extends keyword in Java. So of course, in other languages, the keyword may differ, but in Java, we use extends to inherit the properties and functionalities from another class. So another class here is the parent. So just to explain you in a simple way, we have kept the naming conventions like this. So let's move ahead with the live coding example. I hope that will make you clear. So let's see. So here we are just creating a class inheritance example. So let us create a static void main. I'm just creating a main function to show you how powerful this inheritance is. And let's say here we are just printing inside main function. Okay, nothing else. Fine. This is just simple code where we are just printing one line inside our main Java code. So now if you run this, we will be able to see inside main function. Hooray! Fine. So now let us go to the parent class. So basically, this is the blueprint class. This is also called as the base class, where the actual data members and functionalities are present. So here, let's say we want to define some functionality. Let's say in our case, I'm just creating a random function. Let's say display. So what this display will do? This will just print something on the screen. Let's say I will just say displaying inside the parent class. Okay. So this method is just printing a string called displaying inside the parent class. Okay. And now we are going to inherit this class in the child class. So let's say we have another class defined over here, this child class. So this child class is extends the parent class, which means child class is inheriting the properties and data members from the parent class. So let's check it out in the real time how it behaves. So let us create a, okay, let's name it as a child one, new child. Okay, and let's check out whether the child one is having access. See here. So we have access to the parent class functionalities. So let's check that out as well. Let's run this and verify our code. Ah, here. Awesome. Okay, let me add a new line so that it will be clear for you. Slash n means nothing but we are adding a new line. Let's add a new line here as well and here as well. Okay, so that it will look somewhat similar so that we can understand. So here, yeah. So now we can able to see that we are just inside main function. Then what we are calling, we are creating an object of the child class which does not have any methods and fields, but still it has access to parent methods because we are inheriting the parent class. So that is how it is achieved. And we talked about runtime polymorphism, right? So runtime polymorphism is nothing but when we are overriding the methods which is declared in the parent class in the child class. So basically, right now, if you see to explain you in a more detailed way, so the parent class is having a method called display, and if you want to override the same method public void display. I'm going to override the same method here. But here what we will print is, so here what we will output to the screen is, let's say print that, but we are going to print displaying, sorry, my bad, displaying inside the child class. Okay, let's add a new line. Okay, so displaying into the child class, and this child class can also have its own methods and properties. Okay, it's not limited that we only can able to override the methods of parent class. No, it's not like that. We can able to declare our own functionalities and own data members in the child class as well. Let's say, to give you an example, here I'm creating a method called run, and inside that I will print out, let's say I'm gonna print out, I'm going to print, okay, child is running. Okay, that's great. Child is running. Okay, so this is an example. Let's go ahead and run, and let's see what this displays. So here our main function is actually says main functionality stays as is. We're just creating a child object and we are calling the display function. And now let's see what this display is actually doing. Okay, let's run. Yeah, here we can able to see displaying inside the child class. So here displaying into the child class. So why it is happening? Because in the parent class, we are having the same method signature with the same name. And since we are overriding this method in the child class, this takes the highest priority. So whatever we have overwritten in the child class, that is the one which is going to be executed in runtime. So since it is executed at the runtime, that is why it is called as runtime execution or runtime polymorphism. Okay, and we will also be able to access run, right? Let's check that out. Let's check whether the child one is having access to run. Yeah, we can able to see child one is having access to parents methods, as well as child can have its own properties and methods. Let's run it out and verify that our theory is correct. Yeah, awesome. So here we can able to see that the child can inherit the properties and the data members from parent class, as well as it can have its own properties and functionalities. Okay, I hope this is very clear for you. Let's move ahead, move back to the where we came from. Okay, so now what are the types of inheritance? So now we see what is the syntax of it, and we saw a live coding session of it. And we have to know, right, what are the types involved in inheritance, and what are the types of inheritance that are supported in Java. That also we'll have to be clear on that. So now uh, what we saw right now with an example is an example of single inheritance, which means that we are just inheriting from a single class. Let's say here we are having class A, class B. Class B is the derived class and class A is the base class. So we are deriving the properties and functionalities of A class to B class. So B will have its own functionalities and also it will have access to A's functionalities as well. Okay, so that is what single inheritance is meant by. And when we go to the next type, it is multi-level inheritance, which means that instead of having one dependency, now we'll be deriving in multi-level, which means that suppose we are having class A, class B, and class C. So now let's take an example of class C. Suppose if you are creating an instances of class C, that class C will have its own properties and methods, and also it will have access to B's properties and methods. So since B is derived from A, so the C instance will be having access to both the classes A and B. So C will be having its own properties and methods, and also it will have access to all the above mentioned classes A and B. Okay. So that is what multi-level inheritance. And the third type that we are going to see is a hierarchical inheritance, which means that we have a single base class. In our case, it is class A. So class B and class C, both the classes inheriting from class A. Okay. So both the classes, class B and class C, both are deriving from class A. Okay. So let's move ahead with the next type. So it is multiple, excuse me, it is multiple inheritance. So what do we mean by multiple inheritance? So basically, here our class A and class B both are base classes, and class C is trying to inherit from both the classes, class A and class B at the same time. So it's like extending class A, comma class B. So we are trying to extend from both the classes. So this is not supported in Java. So we will see that we will see the why question in the next slide. But let's move ahead with the one more pending type of inheritance. So it is hybrid inheritance where the multi-level and multiple both are combined. So that is what we call as hybrid inheritance. Now let us answer the question of why multiple inheritance is not supported in Java. So to give you an example why it is not supported, let us take two classes, class A and class B, and both the classes having same method name. Let's say display in our class. So class A is also having a display method and class B is also having a display method. And class C is inheriting both A and B at the same time. So class C extends A comma B, which means that it is inheriting the properties from A and B. So now let's see at runtime, when we try to access the display method from the instance that we created, like we will create an instance of C, and when we try to access the instance of C, and when we try to run that display method, so how the compiler will choose which method to choose from. So whether it's a class A we need to run or from class B we need to run. So this is the ambiguity that happens in the compiler level. So that's why it is not supported in Java. So that's why we will see a compilation error itself. Instead of failing it on runtime, we will fail it at the compilation time itself. So I hope this is clear for you. So thank you for watching this video, guys. Please do let us know if you have any questions in the comment section. See you in the next one.